viewers. My name is Afia Demola Johnson. This is the continuation of the previous video where we titrated. So we want to continue with the calculation. We have found average volume of A. According to this table, we added this 3, which is this, then 3.2, which is this, add them together over 2. You have this over 2, then you have this answer. Then the first question, according to this place, is saying that from your results and the information provided, find the concentration of A in gram per dm3. Let's go back to the question. In the question, they say A is a solution containing 3.35 gram of H2SO4. This is gram, mass. Unit of mass is gram, not unit of concentration. So this is an unstandardized solution of H2SO4 in 500 cm3. It's not 3.35 gram per dm3, but gram in 500 cm3 solution. So from there, we can get the concentration of A in gram per dm3. What do? We will now say 3.35 gram of H2SO4 dissolves in what? In 500 cm3. And when you are preparing a standard solution is a solution that contains certain amounts in mole or in gram dissolving in 1 dm3 of the solution. And 1 dm3 of the solution is same thing as what? 1000 cm3. So, since this one is dissolving in a number different from 1000 cm3, it's not standard. So, we are looking for a fresh mass, S gram of H2SO4 that will not dissolve in 500, but that will dissolve in what? 1000 cm3 of that solution. Now, if that is the case, we come back here. Now, we take this place away. Now, let's take this question part away. Now, from this point, you can have 3.35 over x is equal to 500 over 1000. And we know 500 here 1, 500 here 2. So we have 3.35 over x is equal to 1 over 2. We cross multiply, we have x times 1x is equal to 3.35 times 2. So our x now becomes what? So we have 3.35 times 2. Answer is 6.7. Now, gram per dm3. Now, that is the concentration of A in gram per dm3. No more in gram. What they gave us was in gram. Now, the next question is saying that we should find concentration of A in mole per dm3. They don't want it in gram per dm3 again. They now want it in what? In mole per dm3. So, B now. Concentration of A in mole per dm3. The formula to convert between mole per dm3 and gram per dm3 is what? Molarity of what? Of A is equal to mass concentration of A over molar mass of A. Now we are looking for the molarity of A or concentration of A in mole per dm3 or concentration of A in mole per dm3. So now what do? Concentration of A in mole per dm3 will now be equal to the mass concentration is what we just got, 6.7 over the molar mass don't forget that A is H2SO4. So find the molar mass. That's why we are giving this information. Anywhere we see H, put 1. Anywhere you see sulfur, put 2. Anywhere you see O, put 16. So we now have, the formula is H2SO4. H is 1, but you have 2, H2. Then put plus, S is 32. Plus, oxygen is what? 16. Times what? O4 times 4. So, now, so we now have concentration of A in mole per dm cube will now be 6.7 over, when if you do this one very well, you get 98. Now, so we divide concentration of A in mole per dm cube will now be equal to our answer divided by 98. That is 0.068. We have gotten B part. Now we are going to C. C is saying we should get concentration of B in mole per dm. If you look at the question, what did they say about B? They say B is a solution containing H2CO3 which contains 5 grams per dm cube. You will ignore that concentration, you don't need it, because the formula of because Na has been replaced with a letter X, and letter X is not an element. It's not any recognized element. So what do you do? Now, the formula to use is CaVa over Cb Vb equals to Na over Nb. What is my Ca? Ca means concentration of A in mole per dm cube. So in the question, if you are given concentration of A in gram per dm cube, even though they did not ask you to find it in mole per dm cube, there are some questions like that. They will say A is a solution containing 5 grams per dm cube. In this place, they did not ask you to find concentration of A in mole per dm cube by yourself. Convert it to mole per dm cube by yourself, even if you are not asked. Because Ca is concentration of A in mole per dm cube, not in gram per dm cube. So Ca now is what? 0.068. Our Va is average volume of A, which is our titer value, which was 3.10. Now over, what is our Cb? Concentration of B that we are looking for. This is concentration of B. Then Vb is what? Average titer, our volume of pipette, 25.00. Don't forget that the equation before, the equation was what? Was H2SO4 plus Na2CO3 giving us, okay? This is the equation. So in this place, this is A, this is B. So what was used to balance A? Nothing. It means Na is 1 also. So automatically in your exam, your Na and Nb is 1. So take note of that. Then what do we do? This one becomes, then we multiply 0.068 times 3.10. Answer is this. Then we have 0.2108 over Cb is equal to now 1 over 1. So what do we do? We cross multiply. Now, okay, 25 Cb, sorry. This 25 is going here. So 25 Cb. So if you cross multiply, we have 25 Cb is equal to this whole thing is multiplying 1. 0.2108. Now divide both sides by 25. Cb now is 0.2108 divided by 25. So my Cb now will be divided by 25. 0.2108 divided by 25. My answer is 0.4. Okay. 0.00843. So take it to 3 decimal places. Okay, 3. 1, 2, 3. Okay, good. So answer now is what? Mole per DMP. So that is the answer to that one. So we are now going, let's move to the next question here. You come here. So we are now moving to D now. The relative molecular mass of X2CO3. So D now. The relative molecular mass of X2CO3 now. Now, normally to find relative molecular mass, we suppose to say X, the molar mass of X times 2, but no element is X. Then we are now left with an option. The only formula we can now use is what? Molar concentration equals to mass concentration over molar mass. Then we now make the molar mass the subject of the formula. Knowing that in the question, we were given the mass concentration, but we didn't use it. Because it was X2. We are not going to use it now. So now, we are given, they say, B is a solution containing 5 grams per dm cube of X2CO3. That is the mass concentration. So we are going to use this formula. Molar concentration equals to mass concentration over molar mass. Now, the molar concentration, we have gotten it before. That was the last thing we did. In mole per concentration in mole per dm cube. So that is a 0.008. Then the mass concentration was given in the question, but we ignored it before. 5 grams per dm cube. Then we are looking for molar mass. Then this is over 1. We cross multiply. We have 0.008 molar mass is equal to 1 times 5. So we have molar mass equals to 5 over 0.008. So molar mass will now be 5 over 0.008. Answer is 625. The SI unit of molar mass is gram per mole. So we have arrived here, and the SI unit of molar mass is what? Gram per mole. We have gotten it. Now we are going to E now. E is saying we should look for the relative molecular mass. It's supposed to be atomic mass, relative atomic mass of X in X2CO3. Now, since the molar mass of the whole compound has been found, we equate the molar mass to the compound X2CO3 equals to 625 grams per mole. So we now pretend as if we want to look for molar mass the usual way. These two will come to the back of this set to now become 2x plus carbon is 12, oxygen is 16, but we have 3 there. Then everything equals to what? 625. So we have 2x plus 12, 16 times 3 is 48 equals to 625. So we add this, we have 2x plus 12 plus 48 Answer is 60. So we have 2x. Take this 60 there. We have 625 minus 60. We have 2x equals to 625 minus 60. Answer is 565. Now, to get x will now be 565 over 2. And that will give us answer will give us 282. No SI unit. Now, that is that for that. Then the next question, which is F. Number of mole of A. Number of mole of A. In what? In the volume of the pipette. Number of mole of A in the volume, of A in the average data value. So the formula for number of mole is equal to CV over 1000. Now, what is C? Concentration of A in mole per dm cube, which we had gotten before. Concentration of A in mole per dm cube. That is here. This value is not useful now. That's 0.068. Now, times what's V? Volume of the pipette, that's average data value. That was 3.10. Now over 1000. So our answer will now be 0.068 times 3.10. Now divided by 1000. Our answer is 0.0002. Okay, mole. Extra unit of number of mole is what? Is mole. Please take note. Mole. Now, the next question. We are asked to find the number of X2CO3 particles in 50 cm3 of the solution. Now, so let's come back to this place. Now, that's number what now? G. The number of X2CO3 in 50 cm3 of solution B. So to do that, number is equal to number of mole CV over 1000 times Avogadro's constant 6.02 times 10 raised to the power 23. That's Avogadro's constant. Then our C is the concentration of B in mole per dm cube. That's the molar concentration of B. The molar concentration of B. And that is 0.008. 0.008. We calculated it before. Then times the volume given to us now. They say in what? In 50 cm3 times 50 over 1000. Then times 6.02 times 10 to the power 23. So there we go. We have 0.008 times 50. Now times 6.02 times 10 raised to power times now divided by times 23 now divided by 1000. Okay, so that is 1 times 10 to the power 20 particles. So then H, he said we should look for, is I. So we should find the number of hydrogen ion, which is H plus in 15 cm cube of solution A. Anything number is number of mole. So number of hydrogen ion will give us CV over 1000. Will give us, first of all, 2 times CV over 1000 times 6.02 times 10 to the power 23. How did I get this 2? The basicity of H2SO4 is 2. So we must multiply by 2. So we have 2 times concentration of A in mole per dm cube. We have done it before. Concentration of A in mole per dm cube. Concentration of A in mole per dm cube. Now, concentration of A in mole per dm cube was what? 0.068 over 1000 times 6.02 times 10 to the power 23. So we have 2 times 0.068 then times 6.02 times 10 to the power 23 then divided by 1000. Answer is 8.119 times 10 to the power 19. Now, ions. Ions is what? The SI unit. Then, we move on. The next thing to do here is volume of carbon 4 oxide gas evolved. So let's use this part of the board. So let's take this place away. Now, next one is J. Volume of CO2 evolved. Don't forget, according to the equation we had was what? H2SO4 plus X2CO3 giving us CO2 plus X2SO4 plus H2O. This was the equation. From this place, we are aware that now we already know the gram of this. 1 mole of X2CO3, which contains what? Of mass. What was the mass? That is the mass concentration. Concentration of X2CO3 in gram per dm cube. Did we got it the other time? Now, don't forget that we got the molar mass of X2CO3 the other time. That is standard mass. The molar mass we got the other time, which was what? 625. We are going to use it now. Which contains 625 grams per mole. Now, liberated 1 mole of CO2, which occupies 22.4 dm³ of space. With that, you can also say, okay, mass is mass to volume relationship. So what we are not looking for, what are we looking for? Volume. So since this is the molar mass, then the mass concentration was 5 grams according to the question. It said B is a solution containing X2CO3 containing 5 grams per dm³. So 5 grams of X2CO3 now will now give us what? X volume of CO2. We don't know it. So we now have what? 625 over 5 grams equals to 22.4 over X. We cross multiply. We have 625X is equal to 5 times 22.4. So our X is now 5 times 22.4 over 625. Our X now becomes so 5 times 22.4 then divided by 625. That gives us 0.179 dm³. That's the volume of CO2 evolved. So lastly, okay, we are asked to find the mass of the salt formed. Don't forget from the equation, this is the salt formed. So we are going to use a relationship. Mass of this one, mass of X2CO3 over molar mass of X2CO3 is equal to mass of the salt, which is X2SO4 over molar mass of the salt. Now, what is the mass of this one? The mass concentration of was 5 grams, if I'm not forgetting, 5 grams, and the molar mass is what? 625. Equals to the mass concentration of this, the mass of this one now, mass of X2SO4 now, the molar mass. Don't forget we have gotten our relative atomic mass of X to be 282, right? So we use that one to find the molar mass of it. Now these 2 times 2, 8 what? 2 point what? 0.5. Now plus S, sulfur is 32. Oxygen is what? 16 times 4. Now let's manage this space. Now we now have 5 over 625 is equal to, this one we don't know, mass of X2SO4 over, then let's look for this, 2 times 282.5. Answer is 565. Now plus 16 times 4, that's 64 plus 32. That's 96. So we have 5 over 625 is equal to mass of X2SO4 over, then we add up, we have 96 plus 565. Our answer is 661. So we cross multiply and divide both sides by this. mass of X2 SO4 will now give us 5 times 661 over 625. So that is, this is times 5, then over 625. So answer is finally 5.288 gram. So we have come to the end of this calculation. I hope you understand it very well. So if there's anything you don't understand here, and you need me to share more light, you can put your question in the comment section. So, and I will also advise you to click the subscription button, subscribe, share the video, and so that every other video I post will come to you. I remain my humble self, Afe Ademola Johnson. Thank you. God bless.